Hello friends and welcome to Bosons Botany. So I'm starting with the constituents of a vascular bundle. I have already started this topic but only given you the subheadings. But now I am defining these subheadings. First, xylem. It is present towards the center. It is composed of tracheids with xylem fibers and xylem parenchyma. So these are the components of xylem. The vessels may have thickenings like annular, spiral, reticulate, and scleriform. I think these words are not new to you because I have already described these special type of thickenings and these are also present in case of xylem vessels. Xylem tracheids and xylem vessels are meant for water conduction. Xylem parenchyma is meant for food storage and xylem fiber is meant for support. So these are some important functions performed by these components of xylem. Now the types of xylem on the basis of arrangement of protoxylem and metaxylem. So first type is centrifugal xylem. When protoxylem is present towards the center, this is the end-arc condition. It is found in stem. So end-arc condition and centrifugal xylem is very common in case of stem. Now centripetal xylem, when protoxylem is present towards the periphery or towards the edges, towards the sides, towards the margins. This is exarch condition and it is very common in case of root and also found in stem of Lycopodium. Lycopodium is a pteridophyte. So in case of stem of Lycopodium, the arrangement of xylem is centripetal. And the third type is mesarch, where both the forms are present. Example, ferns. So protoxylem is the first cell of xylem which is present towards the center in case of stem and towards the periphery in roots. It has a narrow lumen. And metaxylem is basically a later developed tissue which is developed later or during the later stage of xylem. So protoxylem is the first formed cell and the metaxylem is the second or the last formed cell. So protoxylem is generally it is small in size and metaxylem is large in size. Now I have drawn here something very important to represent end-arc condition. So this is a vascular bundle and towards the center there are many xylems. I have drawn only two just to show you the arrangement, the pattern, the shape of protoxylem and metaxylem. So if I zoom the diagram here like this, it is very clear that towards the center protoxylem is present and protoxylem is very small in size and gradually the size increases towards the periphery representing metaxylem. So towards the center protoxylem is present which is small in size and towards the periphery metaxylem is present and this pattern is followed like this in a circular manner. So I have drawn the dotted lines here, the dotted circular pattern here to represent their positions in a concentric way. So I have drawn only two of them, protoxylem towards the center like this and gradually the size is increased towards the periphery to represent metaxylem, and this is the end-arc condition found in stem. And if you reverse this arrangement, that is if you draw metaxylem towards the center and gradually the shape decreases and you draw protoxylem towards the periphery, then it will be exarch condition found in root. Now how to draw xylem? In many of your books the diagrams are well explained, but very crucial important things I would like to share in those diagrams. Xylem structure is not very well drawn and students often use that method to represent xylem shape, xylem arrangement. So that's not very accurate figure of diagram of xylem. So xylem is basically hexagonal in shape, as you can see. So hexagonal, and its walls are very thick, so it's very important that you draw two lines to represent xylem like this, or you just make the outlines very thick to represent xylem. So these are two important schematic representation of xylem. Either you draw in this way or you draw in this way. These two are correct, and xylem is hexagonal in shape. But in many cases, in many of your books, you will see that xylem is present in circular ways. This is not correct. This diagram is not correct. This is very important to draw, showing its thickness, showing its structure, its shape, how it is basically looking. When you observe a stem or a root section under microscope, how the xylems are looking under the microscope, how their structure is basically. So this is the actual structure they have. It is hexagonal in shape with thick outlines. So if you prefer to draw two lines like this, then it's okay, or you draw this in this manner by thickening the edges to show thick walls in case of xylem. Now here comes the second constituent of vascular bundle. It is phloem. It is present towards the periphery. It has sieve tubes, companion cells, and phloem parenchyma. But in gymnosperms, only sieve cells or sieve tubes are present. Rest are the things are absent. For translocation, so phloem is needed for translocation, that is transport of food materials. There are protophlloem and metaphlloem as well. So protophlloem, it is formed first, present towards the periphery. Metaphlloem, it is second formed cell or second formed type of phloem component, bigger in size with big sieve tubes and present towards the center. And now a very in a very big way I'm defining this arrangement. Here towards the center we have xylem, and towards the periphery phloem is present. So phloem is basically surrounding the xylem, which is present towards the center, and phloem is present towards the periphery. So there are 4 phloems here. It could vary. So just to show you the arrangement, the position of phloem and xylem. The third component is cambium, or the third constituent of vascular bundle is cambium. It is present towards the xylem and phloem. It is not present in every root and every stem, but it is specifically present in case of dicots, because dicots are known to show secondary growth, and secondary growth is solemnly due to cambium. So cambium is the sole reason for the achievement of secondary growth, and which is very common in dicots. It is a thin strip of primary meristem, and the cells are living and rectangular in shape. And this is the video telling you about the constituents of vascular bundles, and in my next video I will take up types of vascular bundle. Thank you.